Hi guys, welcome to the Information Technology program here at SAIT on iTunes and YouTube. So what we're going to do is we've got a few clips that we're going to go through, various topics in various classes. It's meant to be some supplementary tutorial information. It's not intended to replace class time, but we hope you find it useful. So we'll get started. The first thing we're going to look at here today is IP addressing. And so IP addressing, a type of addressing that's used in networks, an IP address is a 32-bit binary address, and it's an address that's attached to network interfaces. We make that point. The second point is really important to make. Network addresses or IP addresses are not attached or assigned to computers. They're actually assigned to network interfaces that are installed in computers. And it's an important point to make. A good example of this would be a laptop computer. Laptops generally always have two interfaces, two network interfaces. One where you'd plug a cable in to get your network access, the other being a wireless connection. Those are two separate network interfaces within the same computer, and each one actually needs its own IP address. Okay? So it's important to note what we assign the addresses to. Now the other thing we can look at is the general format of these addresses, or what we're used to seeing. And what we're used to seeing is in a decimal format, or decimal number format. So for example, we might have something that looks like that. 192.168.100.2. Now this is four numbers. The four numbers are generally referred to as octets. The reason being that each number corresponds to 8 bits in the 32-bit address. Now I can see that a little more clearly if I actually convert the number, or the address, from decimal format to binary format. And it's important that we know how to do this. We can look at doing that. To do the conversion, all we do is do a binary conversion with each individual number. So for example, 192, if I convert that into 8-bit binary, I get 11000000. If I look at 168, I get that in binary. And I can do this with each individual decimal number, converting each one into 8-bit, full 8-bit binary. Now when I say full 8-bit, that's important because, for example, 100 converted to binary (1100,100). That is the binary version of 100. However, there are only 7 bits there. Each number must be a full 8 bits. So in that case, I have to add 0 on the front to make sure that I have a full 8 bits. Likewise for 2, binary 2 is just 10. I have to make sure I have my leading 6 zeros along with that to get a full 8 bits. There we go. So we have the binary version of the decimal version. And it's important that we be able to go from this format, the decimal format, to binary format, back and forth. The other thing I can note here too, in writing out the binary format, I've separated each octet with decimals. In actual fact, to a computer, there is no such division. A computer just sees 32 bits. We make those divisions because it's easier for us to work with when we divide the address up into octets. Now the next thing that we can look at with regards to IP addresses is the way in which that they're actually categorized. And there's IP addresses. All IP addresses are organized into classes. And there's 5 classes of IP addresses: A, B, C, D, and E. D and E we're going to leave out of our discussion because they're used strictly for special purposes. The only classes that are used for LAN addressing are A, B, and C. So we're going to limit our discussion just to those 3. Class A is distinguished by the range in which the first number of the IP address falls into. So for example, if I'll use my same address again. How I know what class that belongs to is by simply looking at the first number. That first number will fall into a particular range. That range identifies the class. The range for class A (1 to 126), for class B 128 to 191, and for class C 192 to 223. And so I can simply check the first number of any IP address and tell exactly what class it's in just by that. Which range does it fall into? So this particular address is a class C address because this falls into this last range. If I have another address, say 172.16.1.2, I know that's a class B address because this number, this first number, 172, falls in that range. Likewise for class A. And so in that way, I can tell what particular class any IP address belongs to. Now that gives us the basics of IP addressing. There's some further details. For example, IP addresses are structured to identify networks as well as hosts within the address. It's the hierarchical nature of an IP address. Also, there's something that's always attached along with an IP address, and that's something called a subnetwork mask. We can look at what that means. But we'll leave those details for the next clip.